Hi, Colin Bell here with Team Align, and today I'd like to walk you through the build procedure of the T-Rex 800E DFC, which is a fair bit different than the previous 800E Trekker. This is actually very similar to the 700E DFC in the sense that the frame set from the battery tray up is identical. You're going to have a direct CCPM servo swash plate connection. You have the black hardened CNC style gears throughout the whole kit. As you can see, this one comes with a new style of landing gear. The tail fin has a plastic reinforcement ring molded onto the outside of it. So there's a lot of new features and incorporations into this kit, and we'll get into that with more detail as I build a helicopter kit. So at this point you can sit back and enjoy the build. As you can see here, the box outlines what comes with the kit. You're going to get one set of main blades. These are the latest version of the 780mm carbon main blades that are used with the 800. You're going to get an 850 MX brushless motor, the Castle Edge 160 HV speed control. You're going to get 3 cyclic servos, which are your digital high voltage BL800H servos, your 1 brushless tail rotor servo, which is the BL850, and a 3GX flybarless system. This is packaged just like all of Align's kits. You're going to get your main canopy box, which is going to, of course, contain your canopy, but also your instruction manual, some of your tail rotor pieces, your forward gearbox, your skids. In here is, of course, your main blade set, which will also include your tail boom supports, and tail rotor control push rod. Over here you can see the kit comes with a 3GX flybarless unit. This one has version 4.0 in it, but by the time you watch this video there may be another version available, so make sure you go to Align's website to check and make sure that you've got the most up-to-date version. Also within this box you'll find the main rotor head, which is going to be your hub and grips, swash plate, main shaft, etc. And in here is all of your electronics. So that's going to be your 3 cyclic servos, your speed control motor, and your tail rotor servo. So with that said, we're going to open up this canopy box, take the manual out, and then follow it step by step so you can see exactly what this build entails. When you pull the rotor head from the box, this is what you're going to find. It is loosely assembled like all Align components. You'll notice the DFC bolt is loose, the turnbuckle's loose, your spindle bolts are loose, along with the grip posts here. So I'm going to disassemble it all, clean off all the parts, apply some Loctite, and then put it back together. I'm going to do that in a stop motion picture sequence so you can see exactly how it goes together. While you have the rotor head apart, now's a good time to apply a little bit of extra grease to your thrust bearings. All I use is a clear line grease. Because it's got a nice small tip on the end of it, you can easily just push it in between all the balls in the thrust bearing and then reinstall it when you're assembling the grip. Once you've greased the thrust bearing, it's very important that you reinstall it in the correct orientation. As you can see here, we've got the radial bearing followed by the thrust washer, which is going to transfer the thrust loads through the inner race of this radial bearing to the thrust bearing. So that's a very important piece, and you need to make sure that that is installed. After that, you'll see that we've got both races of the thrust bearing with the thrust bearing cup and the balls housed between them. I install it so that the cup is facing inboard towards the center of the rotor head to help hold all the grease in the thrust bearing. It's not going to hurt anything if you install it the other way. The grease just isn't going to stay there for quite as long. Each one of these races is marked in and out. It's important that you put the inboard one closest to the rotor hub and the out one closest to the blade grip. Now that the rotor head is complete, we can disassemble the swash plate and then reinstall everything with Loctite. Just like the rotor head, this assembly is already pre-assembled. However, it's only put together loosely. So you have to unthread all the balls, apply a little bit of red Loctite, and then reassemble it. Once that's complete, you're ready to install the swash plate onto the main shaft, followed by the rotor head. The next process of this build is to assemble the frame halves. It's easiest to assemble one half of the frame first, which is outlined in the manual, using all of the components laid out here. The first thing that I'm going to do is remove all of the hardware from the bearing blocks, the anti-rotation guide, the base plate, and the frame stiffener, and then we're going to overlay everything onto the frame, install the hardware from the other side, and then I'll show you the completed frame half. Here we have one complete half of the frame. As you can see, there's 3 bearing blocks. You have to be careful of the orientation of these bottom 2 bearing blocks. The top one you can't mess up, but this one you can install backwards so that the bearing orientation is up, or that these are flipped around the other way, which are the mounting tabs for the servos, and that's not going to allow your servo to mount properly. Same thing with this bottom one. This bottom one should be mounted so that the bearing presses in from the top, which will allow the tail drive gear to hold it in place. You'll also notice 2 standoffs or frame braces that were not actually in the picture when I put it together. And secondly, over on the other side, you'll notice our frame brace, which is going to support the motor and stiffen things up quite nicely there, which is also attached to a frame member in the back here, and then also our pinion bearing block support. So with that said, you're now ready to assemble the other frame half, your forward tail rotor transmission case, your forward battery speed control, gyro mounting platform, along with the skids. Align has also pre-assembled the tail rotor case and the tail rotor grips for you. The only thing that we're going to take apart completely is the tail rotor hub and grip assembly to check the thrust bearings for grease and the hub bolts for Loctite. After that, we're going to carefully remove each individual bolt on this control idler setup and then reinstall it with Loctite. I find that that's a little bit easier than taking it all apart, having it in a bunch of pieces over the bench, and then trying to fumble with a bunch of small bearings and small hardware, so we'll just do those one by one. I'm also going to check these 3 tail rotor case bolts on this side along with the 2 on the other side for Loctite, and then we're going to put everything back together. Now we're ready to install the motor onto the motor mount and then install our steel pinion onto the motor shaft. To fasten this pinion, you'll slide it over the motor shaft and take note of where this machine flat spot is. That's where one of the set screws is going to bite to hold the pinion from rotating. As you can see, the flat spot is quite long, which allows you to adjust the height of the pinion. So at this point you can apply some red Loctite to the set screw, but don't tighten it down fully. Just tighten it down until it touches the flat spot so you still have some pinion adjustment. As you can see over here, there's one washer that's different from the rest. It's got a larger inner diameter that's going to slide over your motor shaft and space your pinion up just slightly from the support bearing. Once we get this installed in the model, you'll pull down on the pinion very gently until it touches that bearing and then tighten the set screw down to hold it in place. Now you're ready to install your 3 included high voltage brushless BL800H servos. These servos mount onto the mounting tabs that are machined into the top and middle bearing block. That's done obviously to save a little bit of weight. You don't have extra mounting components. You're going to install these with the 4 included machine screws and the carbon fiber servo plates. Your included tail rotor servos first going to be mounted to this aluminum bracket, which is then going to be mounted to the frame. You can mount the bracket to the frame first, but then it's more difficult to mount the servo. So once again, mount the servo to this bracket using the included hardware and the carbon fiber servo plates, and then we'll install it into the main frame. Here you can see our cyclic servos mounted, which are tied into our bearing blocks using the included hardware and the carbon fiber mounting plates. You'll also notice that the output shaft for the cyclic servos, the forward cyclic servos anyway, are pointed toward the top bearing block in the rotor head. Here is our elevator or rear cyclic servo, and this output shaft is pointed aft towards the tail boom and the tail rotor case. Moving over to the tail rotor servo, you'll see it's attached to the aluminum mounting bracket, which is tied into the frame, also using the carbon fiber servo plates, and this particular servo has the output shaft also mounted back pointing towards the tail case. Now we can glue the torque tube bearings onto the torque tube using a little bit of CA glue. We want to make sure that the dimensions between the two bearings are not the same and that they're also not equidistant from the end of the torque tube. So you want to have them offset a little bit to help eliminate any vibration that might be set up. So we're going to glue these on, wait for that to cure, then slide our rubber bearing holders over the bearings, apply a little bit of WD-40 to the inside of the tail boom and also to the outside of these rubbers to help us slide the torque tube through the tail boom. When you're ready to install the tail fin, the first thing you need to make sure of is that the hole in the tail case is lined up with the hole in the tail boom, allowing this index and the tail fin adapter to tie all of them together and act as an anti-rotation pin. Once you've got that installed, you can tighten both of these bolts evenly until the split clamp on the tail rotor case is tight against the tail boom, allowing no rotation whatsoever. Now you can install the tail boom into the helicopter, making sure that when you gently slide the tail boom into the tail rotor case, the splines in the torque tube line up with the splines in the bevel gears. All you have to do to achieve that is slowly rotate the bevel gears as you're pushing the tail boom in gently until you feel everything align, and then you can completely push the tail boom in, tightening the pin here on the other side. Before you tighten the horizontal fin clamp, you should first make sure that the tail boom supports are lined up and in just snug to this clamp. Then you can visually line this up with the canopy standoffs, which I find is a pretty good indicator that this is level, and then tighten this down to the boom, and then finally tighten down the tail boom supports. Now you can build up your tail rotor push rod. The first thing you have to do is thread these plastic links onto the steel threaded portion of the carbon rod at the very end, but not quite all the way. You want to leave 3 or 4 threads showing just so you have some adjustment when you go to set up your tail rotor on the 3GX. The last thing you'll do is glue the steel sleeve on once you've got this link snapped on the back bell crank and your tail rotor control rod guide, which you can see right here, positioned on the tail boom where you'd like it. To glue that on, all you use is a very little bit of CA glue, slide it over the glue, and then let it harden for a few minutes. Here you can see we've got the steel sleeve glued to the carbon control rod with a little bit of CA glue. And what that sleeve does is minimizes any wear or eliminates any wear that would usually happen on the carbon control rod rubbing up against this plastic guide. So you want to make sure that when the tail rotor is in the center of its travel, that this steel sleeve is in the center of this control rod guide. So at each extreme, you'll see that the sleeve does not bypass the control rod guide. If it does, eventually this carbon rod is going to rub on this plastic and cause it to break. So just make sure that that's in the center of its travel when the tail rotor is in the center of its travel. To install the main shaft into the helicopter, simply take one of the 4 included steel shims, slide it over the main shaft until it touches the machine lip here on the top, and then drop the main shaft through the bearing blocks, through the main gear assembly, and all the way down. At this point you can install your lower main shaft bolt through the tail rotor drive gear and then check to see if there's any up and down play between the bearing blocks and the main shaft. If there is any up and down play, you need to remove the main shaft, install a thicker shim, and then reinstall the whole assembly again. If the main shaft shim is too thick, it'll be very difficult to get the lower main shaft bolt through, or impossible, which again means you have to take the main shaft out and then install a thinner shim. So you're looking for no up and down play. You should be able to pull and push up and down on the rotor head and not see any play. The last step of the build procedure on this 800 is to install the canopy grommets into the canopy. But first you have to glue these black canopy protectors from the inside or the outside of the canopy. I like to put them on the inside to protect the fiberglass from cutting through these rubber grommets. So all you have to do is apply a little bit of CA glue around the ring of this plastic protector and then glue it in from the inside. Let it set up for about 15 minutes before you try to push the canopy grommets through.